When people are getting started in electronics, they often say that they want to work on some big project at the end. And working with people throughout contextual electronics, one of those projects I hear about often is to build a robot. This is because robotics have a huge place in popular culture. They're interesting, they can do cool things, they can manipulate things in the real world. It's just a great end goal to have. And one thing that surprises me about robots is that there is a lot more high-level processing once you get above the electronics, firmware, but then also software, and then maybe interfacing with a network as well. And so there's a lot to pile on top of the electronics at the bottom layer. The thing that drives the motor of the wheels is not the same thing that interacts with the camera that it's trying to move around obstacles. And so to do this, there's something called Robot Operating System. And today's guest, Kat Scott, works for Open Robotics as a developer advocate, working with people that are building these systems using Robot Operating System. And we're going to talk today with Kat about how it interfaces with all these different systems and how they're even moving into the world of microcontrollers to build systems that work within the larger robot operating system. We're also going to be talking about open source. Kat's a member of OSHWA, and Robot Operating System is also open source. And so it's just a great view at how we can make knowledge that is enabling these devices out in the real world. We'll talk about some of those as well that are moving things around, moving around things, moving you around as well in cars, and just making robots happen. So I hope you enjoyed this episode with Kat Scott of Open Robotics. Well, welcome to Kat Scott, who's a developer advocate at Open Robotics. Kat, how you doing?
Hanging in there.
Yeah,
it's a nice day. It's a very nice spring day here in San Francisco. So.
That's great. Yeah, and so we're going to be talking about robotics a little bit here today. And I'm really excited about that piece because it's kind of we're trying to talk about things that are putting electronics to use. And I think robotics is one of the very great endpoints of building maybe a small module, working with another circuit board or whatever. But at the end of the day, you want to integrate it into this larger assembly that makes a robot. And robotics is kind of this really broad field, as I'm sure you've seen a lot of now.
It's an extremely broad field, right? And to see what you see is people deploying robotics in a bunch of places you never thought. Like it used to be like, okay, manufacturing, and then like, oh, well, we put robots in other planets, we do research. But the breadth of research, but then the breadth of where people are putting robots now, right? Like agriculture, out in maritime environments, out in oil and gas fields, out in hospitals, in sort of not just manufacturing, but logistics on top of manufacturing, on delivery. It's a proliferation.
Yeah.
And so everything is growing pretty quickly. And it's just sort of seeing like, well, can we do some work over here? Can we do some work over here? And it's really fun.
Yeah. And so are there any unexpected within that? I mean, it sounds like a lot of kind of commerce is really latched onto the robotics thing just because you can start to make things more efficient, more, maybe safer for users. You don't have to put people in dangerous situations anymore. Are there any like really unexpected robotic applications?
Unexpected robotic applications. I mean, you get people building lots of weird, the classic like shitty robot, stupid robot sort of things, which I think are great. I'm mostly, it's the weird ones are the sort of one-off science missions. So like, we got a team that just said, hey, like this spring, they're like, hey, we're going up to Lake Tahoe. We're going to go to the bottom of Lake Tahoe with the ROS-driven robot. And you're like, really? And then they did this like strange thing where they had like, I guess they decided to put an iPhone on the front of it and see like how far it would be good to. And so they drop it down and you're just like, okay, cool. Weird flex, but okay.
Some extra funding that they're like, well, we just got $1,200 to blow. So, we can do whatever we want. That's interesting. I mean, and so when someone is looking to use ROS, I guess I've said ROS, but not what it is, this robot operating system, right? What does that actually entail? Is it kind of, you start from a starter kit? Do you start from just the software? Where are people kind of coming into this world?
Well, so I think it's worth talking about, like how you go about doing it. And for a long time, and the way ROS was originally designed was, okay, there's always the difficult control systems, right? I need to run this thing at 10,000 hertz to get the feedback that I need to do to do the control system, which a lot of times that's done in embedded hardware. But then once you have all your embedded pieces, it's like, okay, now we need to string those all together in some reasonable way and be able to set everything up, tear everything down, test it. And so ROS is
Mm,
really about, it's at the end of the day, it's just a couple of very particular tools that you can use to build robots. So it's like
mm,
encapsulation around processes. It's, communication between those processes, like what kind of messages they're passing, how they're going to pass them, the primitives that you can use, the API primitives that you use to construct things. So, hey, I have this synchronous task that I want to do versus I have this asynchronous task that like this arm is going to go out and do the thing, and when it's done doing the thing, I want it to come back to me and tell it it's done. So it's that. Um, Visualization, debugging, all of those primitives. And then we're so far along at this point that people have taken all of those and started building up higher level things. It's like the evolution of a library, right? You start with linked lists,
yeah.
and then 5 years later, you've got like, a PDF parser or, a library to do geospatial stuff. And so we have like sort of federated friends that do stuff like, here, this is all about controlling and doing inverse forward kinematics on arms. Here's how you just
Oh,
do
wow.
navigation and mapping as like a package that you go
Yeah.
and you fix. Um,
So is it safe
Visualization, logging.
to yeah, is it safe to make like a kind of a parallel to a like a operating system like a Windows or a Linux or a Mac or OS rather, iOS,
Yeah, I
in
mean,
that
it
way?
is. It's a misnomer in the sense that it's not an operating system. It's more of a layer on top of the operating system. But
Oh,
if
okay.
you think of it more as the primitives in the operating system that you would look for to
Hmm.
do these sorts of things, they're all built in and they
Right.
kind of come when you install everything.
Got
And I
it.
guess the other one is package management too, right? Is
Oh,
that
sure.
like, like to use a computer, having a package manager, like every big operating system has a package manager. Well, ROS has the equivalent. It's like, go get this piece of code and wire it in.
Hmm. Okay. And so is it? So you said it's built on top of an operating system.
Hmm.
What is it built on top of?
Well, so ROS 2 generally, we have tiered support. So it's like absolutely everything has got to run and run right is generally on, I mean, it depends on the ROS version, but it's generally on Ubuntu.
Okay.
But there is also in ROS 2 a bigger push to have decent support on Windows and a little bit at like tier 3 support on Mac, but it's kind of eh. And
Is that more
then
for like a simulation versus like an actual like the a Boston Dynamics robot running, running
yeah,
iOS?
it's one of those things like people will run it on their native operating system. I think a lot of people choose to run it inside of a container instead, which,
Yep.
that's generally, it's very rare that unless you have maybe a production environment, you're running all this stuff on bare metal or on your host OS. You usually want to package it all up so you don't clutter up your environment.
Hmm.
So I definitely think that's a better approach. Some of the other flavors of Linux are, you know, weekly supported. But what we've done is we basically said, we've defined the tiers. We say like, you know, this has got like absolute support, everything will get fixed. And we say this is what we
Uh,
suggest you use. And there's sort of the like, yeah, we'll make sure it's pretty okay, but it's not our highest priority. And then there's like,
yeah.
we'll help you if you have time. We'll see what we can do. We're not trying to exclude anyone, but it's not
Right.
our first priority, which I
Yeah.
think
So
makes things
there's not like
clear.
that single path that like you have to do this one thing, but also you're not gonna as you stray, you're gonna have a harder time to actually you're gonna have to submit more of your own fixes and things like that.
Yeah, it's gonna end up being a little bit more on the developer, and
Hmm.
I think that's reasonable. There's too many. If you want to use a operating system that's 15 years old, it's kind of on you, right?
That's
Like
right. That's right. Yeah.
we warn you about these things.
Yeah. So okay, so it's built. We'll say Ubuntu for the. That's just an
Yeah.
easy kind of thing to grasp. I think for people that are Linux savvy, whatever. Um, so then, how do you actually kind of dive down? How do you get to that bottom layer to make a robot leg kick or to make a wheel roll or things like that? I mean, is it just like Python on top of Python on top of Python on top of Ubuntu, that kind of idea, or
Well, so there's two parts of that. Like let me start by talking about the ROS sort of build system, which is super weird and people get confused by it, and then it'll help motivate what goes next. And
Mhm.
so ROS is really old. Like I think, first commits are like 2016, or sorry, not 2016, 2006-ish. And so when that was done, like, it wasn't like it is today. And like, if you wanted to intersperse um, Python, and I mean, mainly Python to C++ and a little bit of C and a little bit of Java and a few other things, there really wasn't any tooling for that. So people went and built their own tools where it's like, hey, you have this really good C++ package. You have this really good Python package. Hey, you have this other really good package that I think we can support. And you want to have a tooling system where I can have all these packages. They're all in their respective languages. Like, we have a bunch of Rust people now. And they're all communicating over a standard message type, over a standard message bus. And that's really the core. And then they're out there running their own individual processes that, sort of conform to an API. So it's really long-winded to say, like, it's very, the build system. So in Rust 2, it's Colcon, and so Colcon basically will smash all these things, build everything, and smash it together for you, and get it all ready to run. So saying all that, like, okay, we have this tooling, we kind of have standard definitions for how things work. So now it's a matter of piecing together your robot. So if you want to do something that's not that exotic, say you like, I don't know, you have a robot base, you don't want to build that, you want to buy that.
Yeah, let's talk about maybe the Turtlebot is like a very common example, right? Like,
Yeah,
that
right.
little, looks kind of like a trash can, or like a Roomba with a trash can on top.
Shoot, mine's downstairs, but like,
Okay.
yeah, okay. Well, there's a little one and there's a big one. So, say the little one is just a package, that comes with all the software in there. But what gets interesting about ROS is like, hey, I have this cool new sensor, right? I have this cool new depth sensor, or I have like this little, hobby servo arm that I want to attach on there, right? And it's got a ROS package, and my Turtlebot's got a ROS package. You can basically put them together, build them all, and start hooking them up and building behaviors fairly quickly. And so that's like a simplified version, right? If you want to go and build, a much more complex robot, it's, that, but you're starting from your first units, right? So like, hey, I have this thing, it speaks serial, I'm going to write this process that communicates serial thing and basically build the interface for that. I'm going to get this camera, I'm going to, build an interface to that camera interface. And then you yourself start building up all the primitives. Usually when you're building a robot, you work from sort of bottom to top, right? You got to get the like hardware, software, or the hardware and the sensors working. And then there's the next layer up where it's like very basic behaviors. And then from there, you're building more complex behaviors and like interfaces.
Okay. So yeah, so you wouldn't necessarily try to like wire everything together and have it just kind of work in like a Superloop that like an Arduino person might do. It's obviously going to have lots of individually tested behavior. So output a video stream, test that the video stream's working, that kind of idea, and then something else ingests that video stream. Is that kind of right?
Yeah. So like an example is like, and this is not perfect, but like, let's take the dumbest, not completely dumb robot, but not a great robot, right? Which is like, I have a camera and I have a servo that I want to run. You have the servo interface, and let's say that thing's running at a certain rate, and call it 100, and then you have your camera and it's pulling in images that say something at 30 hertz. The naive way is that, well, this thing runs at this and this thing runs at this. One side runs at 30, one runs at 100, so it's all running at 30 now. The smarter way to do it is that you're processing the data as it comes in, and you're controlling the thing at the rate it's supposed to run, or close to it.
Okay. So then it does also seem like this is pretty not heavy-handed was the word that came to mind, but it's pretty process or resource intensive as well to do this sort of thing. So what is the brain of maybe like a Turtlebot or a similar level kind of a robot? What's actually in there? Is it like just a simple Linux dev board kind of thing, or what's actually living in there?
On the current iteration of the Turtlebot, I think there's a CR2 board, which is just sort of a breakout board. That is power, motor interfaces, a couple sensors like a accelerometer. I think it's accelerometer and a gyro and a magnetometer, but I'm not sure. So there's all of those on the board in there, and then there's just a Raspberry Pi, and then usually depends on sort of what trim level you want. You have like either an RPI laser, like a very simple LiDAR, or you have like a camera, or you have a depth sensor, right? And so you have that's your sort of suite of sensors and actuators.
Mm.
And
Okay.
sort of the way most people are tying these things together here, I'll send it to you. If you go to navigation.ros.org, there is Navigation 2, which is sort of one of these high level libraries that's all put together for like, hey, I have some sort of depth sensor or some sort of LiDAR, and I want to build a map and I want to navigate around
Mm.
an area, right? I want to set waypoints and say, I'm here and I want to go to there.
Mm. And so then, so you would basically just kind of you'd have some kind of interface layer that says, here's what my input is, like a LiDAR element,
Mhm.
and then here's what my output is. Is that it sounds simple, but it doesn't actually seem like it would be
Yeah,
simple.
that's the simple version, right? So you have like a notion of your robots. It's like move base, right? So you have this notion of your robot's orientation in space, the orientation of the wheels, the wheel odometry, and what all your sensors are saying, and then your map as you're doing your slam, as you're building it up, and you're basically going, okay, well, here's my map. Here's what I think of the world. Hey, I get another LiDAR spin, update our view of the world, figure out what my next step is, go to that next, my next step in space, sort of like move ahead a little bit. Laser spins again, look at the world, make sure I'm headed in the right direction, I'm in the right spot, and then do that, right? And all these things are just sort of happening. I don't want to say they're always, I mean, they're all sort of loops going at their own speed, and they're all sort of asynchronous. But you think
Mm.
about them one by one, right? So you have
Ah,
this mod somewhere in the nav stack. Probably there's this module that says read laser, update map. And then there's another one that's running that says look at map, update, or like look at sensors, update position. And then there's another one that says uh, I'm here, move forward.
mm-hmm. Okay. Okay. Yeah.
And each of those little things is called a ROS node, which is basically a process.
Mm. And then, so the people that are usually interacting with this, I mean, are they usually purely software kind of people, or are the kind of hardware people learning how to build stuff that will work into as a module?
I mean, generally roboticists are, they're a cross-functional.
Right, mechatronic
Yeah,
software.
I was talking to somebody today whose background, was a mechanical engineer, but just we were going over a bunch of code. I know a ton of people like that. We have software engineers that sometimes are doing some mechanical design. We have electrical engineers also writing code. So I think
Well, that's
it's,
dangerous. Yeah. Okay.
eh, I don't know. It's all right. So it's all types because it just kind of takes all types to make these things
Hmm.
go. The interesting thing, and so if I haven't made this clear yet, ROS is really old, right? So 2006. So we're in the process of ramping down ROS 1,
Mm.
and we're in the process of ramping up ROS 2, which is sort of like the Python 2 to Python 3 transition, right? It's
Oh,
like,
okay.
oh, yeah, it's effectively what it's like. It's like, oh, well, you're gonna have
It's
to
like a
change a
hard
bunch of
cut,
stuff.
but nobody actually wants to do it.
It's a hard, yeah, it's a pretty like it's been a few years and there's still 5 years, so
Mm.
we're not that
Got
hard.
it.
And if
Got
there's
it.
a
Yeah.
really clear path and there's a lot of resources that I can help people find,
Hmm.
but there are benefits, and the big difference before is like, well, maybe we had this ROS node that talks serial, um, but there's been a big change, sort of a lot of new tooling in ROS 2, namely Microross, that actually should improve how we do that hardware software interface. So it's actually like an interface definition. So sort of before, right, you were writing a process that would read from to your serial connection and then like read from it and maybe send commands, and that was all um, could be very, very bespoke, right?
Hmm.
And so
Yeah.
now we're moving from something that's very, very bespoke to saying, well, we have a rough idea what interfaces look like. So you're getting a little bit closer to plug and play. Like
Mm.
you plug in a piece of hardware and then the ROS system sees it as like a common set of interfaces.
Mm. Okay. Yeah, that kind of goes towards that question I was having, or maybe I didn't speak it out loud, but the idea of like how would I go? Say I wanted to make a new lidar module that someone might want to buy and integrate into a Turtlebot or similar. What would that? What would it take to kind of play into the ecosystem? And I think there's a lot of interplay, but it seems like some of that would be the software interface kind of side of things.
Yeah. So, generally the way this worked before in ROS1 was you go build your hardware, you put the firmware on there, and then it speaks what it speaks, and you go and build your SDK for the host operating system usually
Hmm.
for the piece of hardware, and then you integrate that into a ROS node. Now you can actually run some of that code on the microcontroller with using
Hmm.
Microross. If you can, and it's fairly new, but if you go to like micro.ros.org, you can go and actually for a fairly substantial list of MCUs and for a fairly sizable number of dev boards. Um, you can just say, okay, this thing will actually, given I installed the right RTOS, and given that I've installed a couple other little packages or a couple libraries, it will actually, you plug in the raw system and it says, hey, I can actually register this thing to be something that runs or delivers a ROS topic. So ROS
Hmm.
topic is basically the pub sub bus that all of ROS runs on. So
Okay.
so say you had a LiDAR, right? The LiDAR, you plug it in and you build your ROS system and you kick it off, and your LiDAR is spinning and it's just constantly delivering a stream of messages saying like, I'm at position A, range 1000. I'm at position 2, range this. And
Hmm.
all of that is basically being streamed into this pub sub bus. And
Hmm.
then your downstream stuff is like you might build a node that collects all of those into one spin. And
Okay.
that's a separate ROS node, maybe running on the host OS or maybe running on the microcontroller. I don't know.
Okay. And then what does the bus look like then? So is it, I can imagine if you had a bunch of things, so if you had like a LiDAR, if you had a webcam, if you had a bunch of other things, or maybe just a camera, not a webcam, and then you had, other sensors that maybe are on there, how do they know not to step on each other when like the bus is free? Is there like a protocol for that sort of thing?
Yeah, so for all of ROS 2, and so things are different between ROS 2 and ROS 1, but ROS 2 is all generally, let's step back. There is a specification for an interface, and we call it a ROS middleware layer, or ROS middleware. So it's called RMW, and that's just the specification of the interface. Um, you can make implementations of that interface. Most of them, by and large, are this thing called DDS. I know it's an acronym, so DDS stands for Data Distribution System.
Uh-huh.
And so what happens is there are half a dozen big DDS vendors, and some of them have implementations that are actually created to run on like an MCU, on like a resource constrained environment.
Hmm.
And so now your device is speaking that protocol over some particular sort of wire with an agent on the other side, and it can kind of just connect right
Just
into
kind of
this
works.
running system.
Yeah.
Yeah, it's still, it should mostly work, right? So the
Hmm.
DDS layer is taking care of it. You just sort of say, you think of it as like a host and port. It's just like, here's a
Hmm.
topic. Once the system's up and running, I should be able to see it.
That's great.
Which
Okay.
it's all really complex, but the to talk about, but at the end of the day, the user side of it is
Hmm.
like, it's a topic. So it's just a namespace. And if you go look at that namespace, there will be something being published at a regular rate, or
Yeah.
you publish something into a namespace at a regular rate.
Yeah. Yeah,
So it's
that
just
that took
big
me a while to kind
extraction
of
for
get
you.
it. Yeah, with like MQTT, that was kind of like my introduction to pub and sub uh, interfaces. But like once you start understanding it, it's like, oh, that actually I still don't understand like MQTT. I don't understand any of the stuff underneath. But at the end of the day, I don't really care because I'm just saying like listen to sensor temperature sensor, and then it
Mhm.
just does it. So that's great.
Yeah, so if you're coming from like software, if you've like ever used like RabbitMQ, or even kind of, it's almost like Redis, right? Where it's just like, I have a thing and I can go check what it is, or I can write to it. It's like
Hmm.
these are fundamental software concepts, and
Hmm.
DDS is just an implementation of PubSub. I
Mm.
mean, there's fancier stuff for QoS and things like that, but
Sure, sure.
for a simple abstraction, you can think of it like that.
Hmm. Okay. Yeah, that's great. So then, what does it look like? So I guess someone who's getting started with like a Turtlebot, right? They're kind of they've bought their first Turtlebot. They install the software onto the Turtlebot. Is that right? Or they also have it on their system and then that talks to the Turtlebot. How does that work?
So generally on the Turtlebot, it has a Pi on it.
Hmm.
Everything's just running on that Pi. Um, and you sort of, the way this usually works, right, is Pi is connected to your to your internet, you SSH
Hmm.
into the Pi, and
Hmm.
you basically run something called a launch file. And what happens is the launch file is this sort of like, it's a script. It's a script that says, okay, start this thing, start this thing, start this thing, start this thing. This thing's going to talk on, you know, on this topic and this topic. This thing's going to talk on this topic and this
I
topic.
see.
And
Hmm.
it's just your script to start everything. And so,
Yeah.
what's cool about that is it like, you can script a bunch of different stuff out. So you can have
Yeah.
like Turtlebot this mode and Turtlebot that mode. And, once you have those scripts, that's like how you actually run your robot.
Hmm. Okay. Yeah, that seems like that's like a high enough level too. That seems, especially if you have some example code in there too, it seems accessible where it's just you're starting up the wheels and then you tell it to go move forward a little bit or whatever. So that's
Mhm.
great. It's great.
Yeah, so you might like as a learning exercise, like, oh, well, let's just go start the camera, or let's go start the lidar, or just start the wheels, and then you're like,
Hmm.
I want to do something simple, like when I put my hand in front of the lidar, it'll turn the wheels left. Like, Bill, you can
Hmm.
slowly compose simple things,
Hmm.
and I
Yeah.
think that's the thing that sometimes can be hard for people to break away from is instead of writing monolithic code, writing small reusable bits that get strung together.
Got it. Yeah. And I think that kind of that dopamine hit of like getting something to happen, like that's so exciting when you get started in any project, and making it nice and easy at the beginning can be really critical. So that's a good example of a good way to get started. So I like that. So on the Microross side of things, I mean, so that's kind of to make devices that are plugging into the system. Are
Mhm.
there anything that, shrinking everything down to be in a super tiny system as well? That's what I kind of thought when I first started looking at Microross. I was like, oh, well, this is for kind of standalone robotic system like small quads or similar type of things. But it seems like it's more the pieces that would go into a larger ROS 2 based system.
So my understanding and I could be incorrect on this, but my understanding of the Microross implementation is that it has at this time a pretty good subset of ROS. Um, so you should be able to do that. Um,
Okay.
I mean, at this point with robotics, like generally something like you're operating with something with an operating system, more likely. Um, you know, at this point, most of your or some at least most of the next generation vacuums and stuff like that, right, are all going to have something that boots
Did you
Linux.
s-
Like it's
did
not
you
it's
say
not embed.
vacuums?
Yeah,
Oh, really?
I think that's kind of where we're at. Like if you're going to do sophisticated mapping and planning, maybe you can like if you're really it's like it's a real trade-off on feature set versus like
Hmm.
and I don't do this work a lot right now, but like feature set versus like how much you're going to save or not save on sort of the chips in the device. And
Mm.
like for complex behaviors like mapping and like path planning, I think you're probably better off getting closer to a Linux operating system.
Hmm. Yeah. Yeah. I guess the only downside is that it higher complexity, perhaps, than maybe someone hacking your robot vacuum. But it's going to happen regardless. Let's be honest. So
Yeah, the Internet of Things, if it's not your vacuum, it's your toaster setting your house
that's
on
right.
fire. But
That's
it's
right.
it's
Yeah.
cool. Your camera's going to record it. You
Yeah.
know.
Right. Right. That's really great. I mean, and so how do you see what is the makeup of the community as well? I mean, it seems like some of this would be maybe academic and research, but then like you're saying, it also is going into commercial areas. So what does the community look like?
Well, so what's interesting about Ross and historically, and like really short story, Ross came out of this organization called Willow Garage, which was like this weird startup incubator research organization in Silicon Valley. But it was really about like trying to tie together all of these academic labs, right? Doing the latest, greatest, most interesting research. So it started off as this federated thing, and it's still very much federated. When I say federated, I mean like loose network of people generally working on their own thing, but we all know each other and we chat.
Hmm.
And so like it's huge, and it started off as an academic thing, but to be real about it, all those academics have graduated, moved on, and started companies and gotten jobs in industry.
Right.
And
They,
so
they like making
now,
money at some point.
well, and so like I looked at Automate, which is the big like industrial conference. So there's Ross Industrial, which is the industrial organization. They actually, we chat, we hang out, they're our good friends, but they really focus on like just industrial applications.
Mm-hmm.
So I was looking at Automate, and it was something like, you're like, that company, I counted, and I'm like, that company uses ROS, that company uses ROS, that company uses ROS. And it was something like close to a quarter of the companies at this big conference were using ROS. And so
Well.
people like, because there was this genesis as an academic thing 10 years ago, people still think that. But if you go and like look at the ROS2 TSC or like the ROS Industrial Consortia, and you like look at the companies involved and like look at, say, the organizations Open Robotics works with or that use ROS, it's like, no, you don't know, man. It's basically everywhere. It's in place, and it's the problem with the BSD licenses. No one's like, if I could have one thing in the world, every robot that ran ROS would have like a ROS inside, like a old
Like
Intel logo
Intel.
on the
Yeah.
side of it, and then
Yeah.
everyone would be like, "Oh, holy moly!"
Yeah.
Like that's how many robots are running it.
That's the only thing different from the BSD license. The cat license is a BSD, but then also has the logo thing. That's
Yeah,
all. That's all it is.
yeah. No, just ROS inside. That's all I want,
Got
is
it.
to like have it on these robots, and people would actually say like, "Oh, wow, there's really that many places
Mm-hmm.
where it's at," because people aren't, like how many companies, sort of crow about the open source that they use internally. They don't. And so it's really hard to tell who's doing what and who's using what.
Hmm. Yeah. Yeah. I mean, so first off, I think there's a really missed opportunity to call it the roster of people. Roster. You could build out that acronym somehow.
I will I
Uh,
will I will credit you with that.
yeah. Right. um, but I mean, you did mention bringing people together as well, and there is going to be a conference coming up this year, right? So when is the?
We are going to try to do an in-person conference, but it's not until November, so I think we have a
Oh,
pretty
okay.
good shot. Or sorry,
Mm-hmm.
late October. And
Mm-hmm.
so it's ROSCON, so we do it every year. We didn't do it last year. We did an online one, but all of the videos for every ROSCON ever
Mm.
are out there. You can go watch them, so you can get a sense of what happens. But it is not an academic conference. It is a very like hands-on building robots, making them work
Mm-hmm.
conference.
Right. So you could like
And
show up and actually take workshops and make things move and that kind of thing as well.
I am right now poking people like, I need you to go write a workshop. I need you to go do a workshop. There's it's a very great place to meet people doing stuff, working in open source.
Mm-hmm.
It's a very good vibe. The CFP, if you're interested in talking about, if you're doing something and want to talk about it, CFP is going to come out in like a week here.
Oh, great.
Yeah, and it's in New Orleans, which like, if you're thinking you're interested and you live in the United States, you should come this year, because it moves every year. So this year it's in the US, and then I think next year it'll be in Europe, and then we go back to Asia, and so we move around a lot.
Mm-hmm. Yep. Yeah, New Orleans is fun city regardless. So
Hmm.
it's a good town. Good town. Okay, that's great. And so you mentioned a thing you had gotten to travel to in the past as well. So this was
Hmm.
some kind of competition. What was that you got to go to?
Well, so one of the things that's going on right now, and I have to preface all of this, like I have to put a bunch of caveats in front of this thing. Like, I'm speaking for myself here. I don't speak on behalf of the DARPA, and I don't speak on behalf of the competition. But I was at, right before lockdown. Like the last thing I traveled to was basically the Sub T Challenge, which is one of the things that Open Robotics helps to build the infrastructure for. But and one of many, I should say, also sort of robotics based competitions that are going on right now. And so the whole um, this competition is effectively, hey, we're going to put robots underground where they can't use GPS. We don't
Mm-hmm.
have maps. And can we send robots into these really dangerous areas and have them actually run around and locate things? And
Mm.
so DARPA's running this competition. There are a bunch of different teams with just incredible technology going into, say, old nuclear power plants. Well, they're not old; they never ran, so there's no radiation or
Mm-hmm.
anything. Or
That's good.
going into caves, going into cave systems, and um, they basically have a set of objectives, right? Go find these simulated people. So they have people, like they have heated dummies, and they have like gas leaks, and they have things that emit
Wow.
noise, and you have to send your robot into this deep cavern and hopefully gather as much of those as you can.
Yeah, it's kind of like capture the flag, but the flag is a person in distress or some kind of dangerous element.
Yeah, and the other thing worth noting about this is that there's a simulation component. So even if you don't,
Mm,
if you're just a software person, and you want to compete, it is completely possible to sort of be part of these competitions because they're all software driven.
mm,
And so you can just build your own, and the thing I haven't mentioned about Ross is, I'm it's like having like two or three kids. Like we can't just talk about the one kid. There's the other kid of Ignition and Gazebo, right? So when you build a robot, you don't want to be in front of that robot all day. You want
mm,
to be able to run your tests really, really quickly without maybe having a robot that can fling its arm accidentally and hit you.
right.
So you use a simulator. So Open Robotics also produces a simulator called Gazebo, or Ignition Gazebo is the newer version, and you can actually use the simulator to do the competitions. So we have these super high fidelity simulation, or we go and help build these super high fidelity simulation environments for these simulated robots to go run around.
Mm,
We have a bunch of like example code of like how you can actually use those and like build out your own simulated robot like piece by piece.
that's
So it's
great.
a really good like set of tools to learn the basics of ROS in a fairly realistic and dynamic environment.
Right. And so what how does a person actually, is it just kind of like their standard sets for maybe a wheel or a lidar sensor or a actuator or something like that? I mean, or is it that you could go and define different elements of it to make it closer to what you actually expect to see in the field?
Well, so the components themselves, right, are reasonably high fidelity simulations, right? So there's like regular cameras, thermal cameras, lidars. Um, with we're starting to get to a point where we're doing some secondary effects on them. I think with respect to, and you should refer to the DARPA website to get the exact details. You get a budget, I believe. It really is kind of
Mm,
like a game. So it's like you get a
yeah.
budget. You can have this component. You can have this robot with these components, or two of these robots with this component,
Mm.
and you sort of configure your robot in the way you think will work well, and then you write the software that kind of fills it out, and you send it on its merry way to go hopefully save the world.
Yeah, right. That's awesome. Yeah. I mean, and so you'd mentioned there's other types of competitions that are out there. What else are people able to compete with?
So the more there's a bunch going on. So um, there's F110th, which is a student-run competition with real robots that they basically have. It's kind of like donkey car. It's just maybe a little bit more like souped-up donkey cars. And the thing I find really interesting about this is it is like all student-driven. It's just like uh, some really wonderful students at UVA and a bunch of other universities. Just like, let's see who can build the fastest self-driving like RC car, and they're building a stack for that. But what's interesting about that is now there's this new competition that's come out called the Indy Autonomous Challenge, and it's actually at Indy Autonomous Speedway. And so we're only very loosely affiliated with this organization. So again, it's like refer to the website for all of the
Right.
specifics.
It's right.
But
Don't
uh,
ask Kat how to enter. It's more about she's a fan and
I'm I
participant.
am I'm a conduit for information,
That's
but
right.
I
Yeah.
don't run all these things.
Right.
Um, so they basically have like the one step below professional Indy cars, and they're trying to get them to be autonomous, and they're actually allowing
Mm.
students to build out the autonomy payloads. And I think the competition is actually going to be right around the time of ROSCON. So hopefully, if we're lucky, there'll be a bunch of cars going around like 200 miles an hour around a track, all with their own student built autonomy stack.
Wow.
And there's
That's
that's only
a lot of mass in motion, right? I mean, with students
well,
controlling it all.
there's like three or four other ones too. There's like I just heard about this one with ships, simulated ships in Norway. There's
What could possibly
virtual
go wrong
robot.
with a ship? I don't. You know,
Nothing has been going on with
humans never have
ships
problems with driving ships, so
ever.
yeah.
Um, but there's been a huge proliferation of all these competitions, which I think it's a great way to learn.
Yeah.
The simulation aspect too has really lowered the bar. I don't want to say lowered the bar in terms of the people competing, but like you don't need to have a
Yeah.
shop. And
Right.
COVID's kind of
Right.
pressed it even further. Like, you don't need a
Hmm.
shop. You don't need to go out and spend $10,000 to put
Yeah.
stuff together. Like, you can build it all in software, like almost like Kerbal.
Yeah. It's
And
like
then
an
like,
activation energy kind of thing. It's like
yeah,
just to get over that hump to get started. It's like, whereas before it was monetary and atoms based. Now it's just,
oh
you
yeah,
got the room on your hard drive.
I've coached first teams. It's a lot of money and a lot of work. And then like, oh, I
Yeah.
can just sit at my laptop and build a robot. Sweet.
Hmm. Yeah. And then how does that map back? So this is Gazebo. You said
Mhm.
there's a different, so Gazebo and one other thing, is that right?
Well, so there's Ignition Gazebo, which is, we just
Ignition
call it
Gazebo.
Ignition. Um, is the new version. Gazebo
Hmm.
is the older version. It's just like
Hmm.
ROS 1 to ROS 2. And so that's the
Okay.
simulator that sort of, we recommend to use with ROS, and it allows you to go simulate your robot, and you can go build a simulated Turtlebot and see how those sensors will work and kind of plug it in.
Cool. Okay. And it does the map then. So if you have a Turtlebot as well, it should almost perfectly match the simulation. Is that the thinking?
That's yeah, in theory.
Yeah.
I mean, that's one of those in theory and practice thing, and that's
Hmm.
actually, that whole space is like one of the, big active research areas right now, is like, how do you build really high fidelity simulations that really map back to the real world, and how, like, what's the error function between your simulation and reality, and
Mm,
how do you
yeah.
actually build the simulation such that, like, if it works in the sim, it works in the real world. And
Yeah.
so that, it's an active area of research, and it's better. It's certainly better than nothing. It's certainly wonderful for like writing software tests and other things like that too.
Totally. I feel like in popular culture these days too, seeing like the Mars lander every time, I'm just gobsmacked thinking about all the different scenarios they've gone through. And there just must be so
Mhm.
many simulations we're not seeing that are happening behind the scenes. They've tried everything, they know everything. I'm sure that maps perfectly because we got NASA scientists working on it. And
Uh,
yeah, yeah.
okay, so this super exciting. Like, NASA just said that one of the aims, the Viper Ames mission, we are not on going to be on a rover yet, but
Mm.
they are using ROS to do some of the ground based processing systems
Oh,
for the
cool.
rover, and so we're so excited. It's like
That's really great.
they're actually talking about how do we get more open source. And again, I'm not speaking for NASA. It's just,
Right.
this is what
You're
they
just
said. Hey,
excited
like,
about the fact that Ross is in there. Yeah, that's awesome.
yeah, because I learn about these things and I'm like, holy moly, we're in
Yeah.
space, we're on this
Are they going to
ship,
put a
we're going.
sticker on it though? Come on, they got to put a sticker on
I would really appreciate it if I will send you stickers if you're building a robot. Just email me, I'll make it happen.
Got it. That's good.
I,
That's
I'm
a
gonna I'm
promise,
gonna live
folks.
to regret that.
Yeah, yeah, that's great. Wow. I mean, so kind of scaling it back now again to go back to the hardware piece. Are you seeing you mentioned like a lot of the open source nature on the software side? Obviously, all the ROS stuff is. You're also involved with the open source hardware group
Association.
association. Sorry.
Yep.
Are you seeing now some of the hardware components being open source as well? I mean, what is the? I
Hmm.
mean, you see both sides of it because you're involved in the open source hardware association as well.
Yeah, I
So,
think it's, well, so OSHWA, right, are the people who have sort of, help build standards and build policy around open source hardware, and what that means and what that looks like. And so, like, a year ago, well, so a little bit longer than a year ago, we started building out this certification program, where you could kind of say, like, send us the thing, tell us how it's documented, tell us where, who you are, what it is, what it looks like, what your documentation standards are for different components of the project. And, we'll have a person look at it real quick. And if it sort of meets what we've, like, as a community decided is a standard, we can give you a little number and say, like, this is a certified open hardware project. Like, this is, bona fide open hardware. And all of that is now going into a database that you can search for. So, you know, it's sort of an addition to, say, like GitHub or Google, where you're like, hey, I want to go build this particular component, or, this particular board or this particular thing. I can go and search for it and see if there's an open hardware version.
mm, yeah. Yeah, and so yeah, I mean, I have it on the screen here too of the robot specific things. You can go and see all of the different elements that are tied in to being robotic. So that's great. And they are kind of throughout the world as well. I'm always impressed by that. The people, so it's a country specific numeric system, like a serial number almost. It seems like, And then yeah, there's a bunch of stuff in the robotic space.
So I pulled the numbers. I'm in the process of putting together a report for 2020, and uh, for various reasons, I was only able, like, we had between May of 2020 and the end of 2020, there was something like 750 certifications.
Wow.
It's most of the stuff there is like your normal power law, where it's just like most of them from the US and then some from Germany and some from a couple other places. But about once a month, I go read through them all and then write an article for Make. There, we had one from Mauritius, I think. You're just like, I don't even know where this is. Like, you're
I
like,
don't
I
know
have no
this.
idea where
Yeah.
this country is. And then you're like reading about it. And you're like, small island nation off the coast. I'm getting like, and they're
Cool.
like building their own hardware projects and getting it certified. And you're like,
That's
that's
great.
so cool.
Wow. That's And what is the? I mean, so in on the certification side of things, like what is it? Is it just that documentation piece? Is that right? Just to get that once you've got that there, it gets the stamp, another sticker.
Well, it's another sticker. It is effectively saying, right, that, like, as a community, we've decided that these licenses work well for people, and that if you're going to have documentation, your documentation looks like this or is under one of these licenses. It's not super prescriptive, but there are all of the licenses out there are a continuum. And so if you say, well, we're going to say that the continuum basically starts here and goes to here, we're checking for that. We're checking for, are your hardware files like one of these licenses, like the CERN license? Are your software files, one of these sorts of open source licenses as well? And that's really all we're looking for.
Okay,
Um,
that's great.
and that's to make sure that it's like, oh, open hardware, like, well, we told you what the pinout was. Or so, it has to be a little bit more than that.
Yeah, yeah,
Because the,
that's
the,
good.
the definition was ambiguous, and it's like, no, there's a formal definition, and we can help you, like, make sure that that definition is clear.
hmm And there is another, so not Open Robotics, but they're not ROS rather, but OSHWA is going to be having a conference as well coming up very very
Yep.
soon.
Yeah, it's on the 9th. It's a week from Friday.
Okay, yeah. So
So
we're
that
recording
one's going to
the
be all
30th of March.
virtual.
Yeah, yeah.
We always have the best hardware goodie bags that I think just got. I wouldn't be surprised if they start coming in the mail real soon.
Okay.
Um, yeah, and
What
that's.
what can people expect if they attend that virtually?
I did reveal the speakers. I mean, to be quite frank, it's the same thing that we've all been dealing with the past year. A lot of talk about, like, open hardware and COVID. Like, how would we
Mm,
build? How do you license, build, distribute, iterate on open things generally for um, the medical industry? It's not all that. Like, we definitely try to get a variety of talks, but that's what a lot of people are excited about and have, like, a lot of sort of like reports on their experiences.
hmm
There's a panel about open hardware. Of course, there's going to be some RISC-V talks, I'm sure. And what else is going on? Yeah, I mean, the whole thing is published. There'll probably be, some showing
Okay.
off of badges,
Yeah,
that
we'll
kind of
link all
thing.
that. We'll link all that stuff in all the links to the talks and the conference, and that's great. Uh, It's always nice that it is super accessible when it is all online. So that's always helpful.
Well, yeah, and I think the other thing this year is that just because there's no travel involved, we have, like, unlimited scholarships. I don't know if they're closed yet, but up until like a week or two ago, there were fellowships. Basically, if you needed one, no one would be turned away for lack of money. That was
hmm
definitely going on this year.
That's great. So one thing I wanted to also bring up is I think I first met you when you were working on a bunch of computer vision stuff. So you have that in your background. I mean,
Hmm.
Python based, and how does that kind of lead you into this ROS space as well? Like, I mean, so I feel like there's more and more projects that do have CV in it,
Hmm.
but what was your background that you got into kind of the computer vision space?
Yeah, I mean, computer vision. I mean, that is my background. Robotics and computer vision, they always kind of line up, right?
Yeah,
Because you're either
right,
like
right.
using the camera to go move something, or you want to go, like, you know, fundamentally all robots are, sensors, actuators, and smarts. And so, like, you're
hmm
either like,
You're
deep
looking at
mech.
stuff or you're doing stuff.
Well, you're either you're like a mechie building the hardware, or you're more like,
hmm
I definitely have more of a sensors background. Like, you're building a
hmm
sensor that detects this thing, and you're like quantifying what you've detected. and validating that, it works well. So my background is always computer vision, which, that as in generally in robotics, people have now said, well, we're fancy. We don't call it computer. We call it perception, right? Because we have
Oh.
LiDAR and other, we have other stuff now, not just cameras, like we have depth
Mm.
cameras and we have LiDAR.
Hmm.
Um, but it always ends up being a component in robotics. And I mean, it's incredibly important now because you're using it to, do some of the more finer, fiddlier things when you're doing like vehicle autonomy or
Hmm.
service robots or, just general navigation tasks. And so, you know, if I had to go, I always look at it as a computer vision problem when I'm building a robot, but, that's why ROS is relevant. It's like, well, I got to get the images off the camera and then I got to do stuff with them. And
Yeah,
then I
right.
got to go do more things with them. And it's like, this just makes sense.
Hmm. And so, yeah, I guess that's what my kind of like when I really think about the rubber hitting the road in these kind of situations is what is a like a CV, like a camera module that maybe has depth? Like, what does that spit out? Like thinking about those interfaces. It seems like with ROS, you don't have to think about it as much. That's nice. But
Mhm.
thinking about like someone like you who's done that kind of low level and programming it to understand a better model of detecting a person's in the frame or whatever.
Mhm.
What does it spit out then?
Well, what does it spit out? So it spits out generally standardized messages in ROS, right? So
Hmm.
as much as possible, we recommend that people use standardized messages that are all kind of been defined, right? Like
Hmm.
what's great about that is, you know, hopefully most cameras only vary by like how big the image is, maybe the bit depth, right?
Yeah.
And so like if you have a standard interface and you have a robot, um, it basically you define the message size. It says my bit depth is this, my resolution is this, the speed of the camera is this. And with ROS that message is standardized. And what's cool about it is if you have a robot, you can yank one camera off, say it like doesn't have
Yeah.
the dynamic range that you need to actually solve the problem, and then you attach a different camera. And I'm not going to say it will just work,
Right.
but
Right.
it'll a whole lot easier to go and make it work. And that was one of
Right.
those things that sold me on it, right? Is that like, oh, I can use basically the same message format for all of these different kinds of cameras.
Mm.
Um, I mean, the higher level perception stuff, I don't have as much visibility into how organizations define their messages, right? But you can
Hmm.
like, I'm sure if you look at some of the videos that people do release of like say their autonomy stack, if you go look at like some of the stuff Cruise or I think Ford's put out a bunch, you usually see the same things. Like you see like, hey, here's the vehicle trajectory. You have like little boxes around people, you have little
Yeah, that's what I
boxes
think
around
of.
other vehicles.
It's like
That,
dog, like
yeah,
traffic sign or
well,
whatever.
you you're basically okay. The way I define computer vision is always think of it as like throwing away as much data as humanly possible as fast as possible, right? So, like,
Okay. Yeah.
if you have a bunch of LiDAR data, high fidelity LiDAR data, high fidelity camera data, you are like reducing this, 8 megapixel image to 8 boxes, right? That are like
Hmm.
center of the image or, center of the image and then like top left corner or something,
Hmm.
some reduced dimensionality representation. And so usually at least in ROS, people are probably spitting out lists of those. I don't get a lot of oversight or insight into how people represent them. Actually what would be helpful if you're interested in it, I haven't actually dug into it. So I didn't talk about AutoWare. So
But
like again,
auto work, you said?
AutoWare. So basically ROS has this federated thing. Like I said, we have an industrial branch that's just a bunch of people doing industrial stuff. We have a bunch of people just doing vehicle autonomous. So
Mm.
AutoWare.ai should be it. And so
Autoware. Okay. Yeah.
you want .ai because that's the new one, the fancy
Got
one.
it. Got it.
I don't know if they
Okay.
have those, but it's the same thing that we actually did a lecture series. I did all the basic ROS stuff. I didn't get to do all the cool perception stuff.
Hmm.
um, but they go through and walk you through all the different steps of building those sorts of autonomy stacks
Hmm.
and sort of what the components are, with real world ROS examples of what we've done.
Mm. Got it. ROS bag files are.
Mhm.
Is that like a data file? Is that kind of the idea there?
Oh, yes, that is ROS bags are amazing. They're one of those
Okay.
things that sell you on ROS right away. So like and it's less interesting for images because we know that we can just store image files, right? And you store them as a sequential number. Everyone, like, when they start, oh, I'm just going to dump everything to a file or, to disk in a directory. Well, in ROS, what we've actually done is you have this whole pub subsystem. And so let's say you have a bunch of information about your vehicle, where it's heading, what its positions are, how fast the wheels are spinning. You have, uh, 8 cameras running at the same time. You have 4 lidars, radar, blah, 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 blah. What if you could just dump that to file with a timestamp and then replay it
Uh,
and inspect it? And
yeah.
so that's a bag file. It's
Hmm.
basically like a black box recorder for any robot,
Yeah, that's a good example. Yep.
which is really cool, not just for building the robot, but really cool for doing all of the machine learning stuff that you might want to do um,
Hmm.
as you're building these robots. And you can just take a little snip of a bag file and use it for testing. So you can do automated tests. Like, you know, you always wonder, like, because I live in San Francisco, we have all the autonomous cars. I always, do weird stuff when I see them to see what they'll do. I like try to mess with them, a little
Yeah.
bit, and
Got
like,
it. Or like from behind like a mailbox or some kind of concrete barrier, maybe.
yeah, like Ministry of Silly Walks, like throw them off. But they, you know, if they don't respond correctly, I'm sure somebody has to write a test for that, right? And so you got to
Hmm.
wonder that if somebody, like, when they see you doing something weird, if they bag it up and then use it in a test file, because that's what it's there for, right? Is to grab this little space of the world as the robot saw it and replay it.
Yeah. Hmm. How much is there like in cars? I mean, are there proven? You mentioned like there's it's hard to tell when there's stickers on the side of things. Are there
Mhm.
stickers on the side? Are there going to be stickers on the side of cars that are running ROS? Or are there any
Um,
public examples?
Well, I would point, AutoWare, most of the AutoWare devs overlap a lot with Apex.ai, which is a startup
Okay.
here doing vehicle autonomy. What's interesting about Apex is they build AutoWare, and then I believe their business model is to have a layer on top of AutoWare that's their certified standard. So they
Hmm.
just got a bunch of ISO standards for vehicle safety, which I think is, a big step for us. And I don't know who their downstream customers are, but one's
Okay.
got to
Yeah.
believe if you're building like safety certified
Hmm.
vehicle
Yeah, they're not
autonomy
doing it for
stacks,
funsies.
yeah, they're not doing it for funsies. So I don't have a lot of insight into who's using it, but I know that. I also know that Ford released a giant data set of bag data, right?
Mm.
Like,
Yeah.
there's a big, huge website, and they're like, "Hey, we drove all over the place. We drove in Michigan in the winter with snow, and here's our data. Go have fun with it." And
Yeah.
it's all in a ROS format, so you can kind of assume that they're using ROS at least to capture the data, if not to do something with it.
Yeah. Yeah. That's great. Hmm. Yeah. It's you had brought up before the show as well, like kind of the thinking. A lot of these are very very high level topics. I think about
Mhm,
like most of the time I'm dealing with resistors and capacitors and low level things, maybe a UART, like, and this is just like many, 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 many layers above. But
mhm,
you actually brought up a really interesting point about automotive things before we started recording about like, how do you start to get automotive
mhm.
like ROS elements or similar talking to one another?
Yeah, so there's another automobile. Everyone's dealing vehicle autonomy. So there's the DOT, Department of Transportation, the National Highway Safety Transit Association, has an open source autonomous vehicle stack that they've been working on called Karma. So it's sort of a fork of AutoWare.auto. But from talking to them, and I'm not speaking for them. They have a whole. Yeah, I would go look at the website and understand, read through what they're doing, but they have a strong goal of, well, people are doing autonomy, but what we're really interested in is how do we leverage, like, if we're going to have all these autonomous cars or autonomous cars and regular cars for a while, how do we figure out how to make all of those vehicles communicate, right? The thing that's always struck me
Right.
about the autonomous car stuff is it's so inward focus. It's all about building this vehicle versus building the system, right?
Right.
Where all the cars talk. And,
Right.
like, if all the cars talk, it actually makes the navigation easier because the cars are
Right.
saying, oh, I'm slowing down. And then you don't have to, like, worry too hard. And
I was
then
wondering
also,
about the fact that like if you I know that a lot of them are moving away from LiDAR or whatever, but I always thought about like two autonomous cars next to each other and then just like blinding each other with LiDAR, just like having the lasers blind one another's sensors. I don't think that actually happens, but I wondered how that would interfere with one another.
yeah, but like it's sort of the short-term thinking versus the long-term thinking. Like in the
Mm-hmm.
limit, if they're all those, like what's the easiest way to do it? And maybe the easiest
Mm-hmm.
way to do it and the safest way to do it is to let the infrastructure say like, hey, slow down ahead, and all the cars just proactively slow down to 30 miles an hour and get in the left lane, or they like the cars negotiate and say, hey, we're all headed to Vegas, like get in our caravan, and then they all get in a caravan and like save fuel.
Mm-hmm.
And so I think those are kind of like those are the space of questions that they're interested in solving.
Mm-hmm.
And I think they're just their current interest is in basically like doing small fleets of vehicles moving around,
Okay,
which is
that's great.
it's really flattering and really exciting to say, like, see them saying like, hey, we figured we just used this open source software that you guys happen to help with, and you're like,
Right.
sweet,
Yeah,
cool.
yeah, that's great. Well, we'd love to talk more. Right.
Yeah.
Well,
um
from robots, from Turtlebots all the way up to cars, this has been really interesting. Where can people find out more about you, about Open Robotics and ROS, and then OSHWA as well?
okay, well, the OSHWA website is fairly, I think it's oshwa.org, so
Mm-hmm.
open source hardware to HW a association. um I would generally, if you want to get kind of caught up on ROS, you either should go look at the ROS2 documentation, or we have a users forum. So it's discourse.ros.org.
Okay.
Um, there's also the Microross website if you're more in the electronics domain. But discourse is a good place to go, sort of. I would sort of lurk for a little bit and watch what people are talking about,
Yeah.
what they're doing. But we can kind of help to get you into this huge community of different stuff going on. So those are
Yeah.
probably the biggest ones to go look at. And so that's where
Okay.
I also, like, I do like a weekly robot rundown of like all the packages that have gotten released and all the hardware that's getting released, and like, if startups have a financing round, and anything I see during the week, because I'm kind of
Mm-hmm.
talking to everyone.
That's great. Yeah, that's a great way to keep. I think you're right. It's just you got to kind of ease into it. Don't be like, I'm going to build a car tomorrow. It's start easy. Keep
Start
and I
start
think
with a Turtlebot, or
yeah, or
start.
simulation like you mentioned. That's a great low impact way to get started and try things out. So that's really cool.
Mhm. Yeah, those are probably the best places to start right away. And I can also point out to like the AutoWare video series. Like if you're interested in vehicle
Mm,
autonomy, it's just, a bunch of these senior engineers going on about their favorite thing and what they do and the math behind it and stuff like that.
cool.
Um, there's also in that post, in the sort of DARPA post, I actually go and point to where you can run all the simulation code. So if you want to get started that way, that's a great resource to get started with.
Okay. Yeah, that's great. To go save people from a inactive nuclear plant or whatever. So that's
Hmm.
great. All right. Well, thanks so much, Kat. This has
Yep.
been a really interesting insight into the world of robotics, and I hope people take a dip a toe into the pool.
Cool.
Thanks
All
so
right.
much. So that's our show with Kat Scott of Open Robotics and OSHWA. I was really excited to hear about all of the different developments and how ROS is moving into a new stage of software, but also it's moving into more devices, and even devices that are going to be moving us around in autonomous vehicles and moving around us and moving our stuff around at factories and in an industrial setting. Always very exciting things there. You can learn more by following some of the links in the show notes that are at contextualelectronics.com. We have a new podcast page that features all of the episodes of Contextual Electronics, but also specifically this page you can find from contextualelectronics.com homepage. And yeah, please go and learn about it. You can go and simulate some of the robots on your own. You can learn how to get started building robots or using the Turtlebot or other platforms that are out there. It seems like there are more resources than ever to go and build a thing that is out in the world, interacting with other people, and robots are just cool. So that's all for now. Please do share this episode if you liked it. We're on all the major podcast providers, Spotify, Apple Podcasts, Google Podcasts, and you can also go on YouTube. It's really great if you wanted to share a particular part of this episode. You can always deep link to a part of that video. We really appreciate it. If you don't know, contextualelectronics.com is a course where you can learn more about electronics and build some of the things that might go into your future robot. Please go check that as well. We have a free week for anyone who is interested in trying out the program. That's all for now. Thanks for watching, and we'll see you in the next episode.